Hello all, welcome to this session on Industrial Data Ops for bridging OT and IT gap. Integrating operational data, both in terms of tag and asset context data from multiple systems, is a critical aspect in solving many of our customer business challenges using AWS services. Today, we are going to be talking about one of our tier 1 partners, HighByte, that support industrial data operations at the edge. In this presentation, we will first set the stage on the importance of industrial data ops and how partner solutions such as HighByte play a critical role in enabling us in bringing OT IT data into AWS Industrial Data Platform, followed by a detailed discussion by our partner regarding the various use cases HighByte Intelligence Hub addresses, including their overall architecture. That said, my name is Rajesh Gamatam. I'm a Principal Partner Solutions Architect for Industrial Software at AWS, and I'm joined today in this session by John Harrington, Chief Product Officer at HighByte. John, would you like to introduce yourself?
Yeah, thank you, Rajesh. John Harrington, I'm the Chief Product Officer at HighByte. I have approximately 15 years of experience in industrial automation and this part of the industry, though I've got over 25 years of experience in the technology for manufacturing industry. So looking forward to the conversation, looking forward to our experiences with AWS and to sharing a number of use cases that with our customers have been very successful integrating data into the AWS cloud.
Great. Thanks, John. Now, let me first define the problem that we continuously run into working with industrial and manufacturing customers. Manufacturing and industrial customers today have siloed data sources representing key business entities such as assets, processes, materials, and people. The key challenges faced today is in creating meaningful contextual information at scale. Industrial Data Ops on AWS, with the help of partner solutions, completely removes these silos, making unified IT and OT data sets universally accessible to our customers at low cost and format the data in the right context for immediate consumption. This enables the large set of use cases that underpins any digital transformation and empowers business teams to improve operation and automate industrial processes at scale not previously possible. So if you look at this diagram, we think of a mental model in terms of different use cases being streaming data, batch data, and process orchestration data. Because the type of data is very important, as a lot of type of data that is being collected from sensors is pretty important, for example, like near real-time predictions, whereas historical data that is being collected in industrial historian is a different type of data in itself, and they are utilized for training machine learning models, for example. So we need to understand the use cases that one is trying to address. We would like to envision the categorization of some of the design patterns using middleware software such as HighByte Intelligence Hub so that we can enable the green layer as shown in the diagram. So here in this layer, for example, the data ops team who knows the data very well can create KPIs, for example, KPIs that exposes all the heat exchangers across all the plants belonging to an enterprise from across the world. So in the industrial data ops journey, we see that it has been divided into 3 different categories. So here at the bottom layer, we have the data ingestion layer, where we connect to PLCs, industrial historians, ERP systems, and many others. And we have the centralized system, which is the AWS Industrial Data Platform, where we are able to collect and store information. Lastly, the business and operation insights, where we can do the analysis and take actions on those inferences. So we see partner solutions being critical component, uniquely enabling these different layers. So at AWS, we have been working on solutions that addresses different customer challenges. So at the edge, namely at the factory or industrial facility, we have systems such as industrial historians, such as most popular like OSIsoft Pi system, HighByte Intelligence Hub, and many others. They are excellent in creating asset contextualization and near real-time data ingestion at this level. Of course, at the AWS level, we have IoT services such as AWS IoT Sitewise. But one of the key challenges is to say where the asset contextualization needs to happen. Different folks have different perspectives. But predominantly, customers prefer to have asset contextualization, aggregating data from multiple systems at the edge layer, where software such as HighByte Intelligence Hub play a crucial role in industrial data ops. To this end, we have been working closely with HighByte team for the last 2 years to address various customer use cases. And now data can be brought in securely into AWS Industrial Data Platform to address many of these business challenges. With this, I will pass it on to John from HighByte for an in-depth presentation about their platform. John?
Thank you, Rajesh. Um, and first, I want to start off by introducing a little bit about HighByte, and then I'm going to talk a little bit more about this whole data ops concept, and then we'll get into those use cases and talk about how customers are actually solving problems today. So HighByte is a software company based in Portland, Maine, with a core focus on creating digital infrastructure software to enable manufacturers as well as other industrial companies like the energy industry, the power, oil and gas, renewables, and companies that are going through digital transformation and Industry 4.0. We have companies or customers across a wide range of manufacturing industries and across the globe. And we have partners, including AWS, who can support those customers um, and help them in their deployments of HighByte software. So I want to start out similar to Rajesh. I'm going to start out at the top level, the digital transformation level. So, companies often have goals or digital transformation strategies around optimizing their operations, revenue streams, new revenue streams, more sustainable operations, and really trying to accelerate time to results in driving their business. Those enterprise strategies and goals get broken into projects. They fall into different categories: smart manufacturing, supply chain, production and asset optimization, sustainability, and those get broken into projects like improving quality, increasing your equipment productivity, reducing your inventory costs, lowering your OT and IT costs. Now, as Rajesh just explained, AWS has a series of services to deliver on these, to work with data so that people can analyze and visualize the information so that they can deliver on these projects. And of course, in a typical industrial company, manufacturing or other industrial companies, you have a lot of data sources that are still in general on premise. They're running at the edge. So systems like an OPC server or a SCADA system or a historian, a time series database, your MES, your ERP. You've also got sensors and PLCs and machinery on the factory floor that have massive amounts of information that could be really powerful in delivering on these projects. And databases all over trying to manage and maintain and log information that's happening. The challenge is, how do we make this connection? And how do we get this data up into those services in AWS Cloud? And it's not just about making a simple connection. It's about having a scalable and automated and agile and maintainable an edge native connection that allows you to move this data up. And when you're moving the data up, you really need to contextualize and make the data usable where it lands. Because a lot of the people that are utilizing this data are less familiar with the systems that are running at the edge. So this is where data ops comes into play. Now, data ops as a term and as a concept was really created in the IT industry to focus on the connection, the collection, the curation of data for analytics and visualization. But what companies have found is that on the industrial side of the business, we really have some different challenges. And so we have those same top level problems of curating data for the cloud and for analytics and visualization, but we need some new tooling and some new solutions and some new processes and team members in order to solve it in an industrial environment. And that's where industrial data ops was born. So if you look at it, it's really a discipline within a company. It consists of processes, people, and technology to deliver on this capability. And the concept on the process side, it's a lot of concepts that have been in the IT industry for a number of years, but generally were not uh, adhered to or used in the OT side. So things like data contracts when you're integrating systems, data governance, semantic data definitions, and thinking about the architecture of all of your systems and how information is moved. On the team side, it's taking what used to be an OT team and an IT team, and it's merging the disciplines together, not necessarily the departments in many companies, but working together collaboratively so that you start to hear people like information architects or system architects that are working with the OT team to architect out how we're moving data and how we're structuring it. And it's also including the line of business. So the people who are using this data and allowing them to influence what data do they need, how do they need it, how frequently do they need it, so that when they get it, it's usable data. On the technology side, we're seeing a lot of new technologies. You're starting at the edge, and of course, the edge is very important in industrial environments. Whether we're talking about a factory and the edge is right beside the machinery, or we're talking about an oil field where the edge is the well, or we're talking about a power infrastructure where the edge could be the meters at the consumers' homes or the meters at the solar panels. So the edge is as close to the device as possible. So we need to start there. We need to integrate the data. We need to utilize concepts like the unified namespace and leverage data models and open standards to enable our ability to move data across our enterprise. So if we go back to our digital transformation view of the world, and we saw how we had these AWS services and we had these data sources, industrial data ops really fits in that gap. It provides connection, the ability to collect data, curate it, standardize it, maintain those connections and standardizations, secure the data, and then to be able to govern, not just within a single site or within a single machine, but to be able to govern across the enterprise. And that's really the goal of your industrial data ops team and discipline. Now, how this is put into practice is HighByte has developed a solution called the HighByte Intelligence Hub. And the HighByte Intelligence Hub is a software application that's focused on the scaling and the agility of industrial data ops. The first thing that you'll notice is that it takes a hub and spoke approach to architecture. So this is very different than our traditional OT systems where people are very familiar in many cases with the Purdue model or the ISA 95 model, where we have a layered approach to moving data. We start at the IO, which is referred to as layer 0, and we move the data up through the PLCs, through the SCADA and MES, up to the ERP system, which is level 5. And data moves up and down through that system, traversing each layer. The challenge is that that doesn't work in our new world of moving massive scale of data. And in many cases, data is not needed at different layers. So now with a hub and spoke approach, we're able to ingest data from all different layers, merge it together, and deliver it to the cloud. The Intelligence Hub also establishes a data modeling and management abstraction layer to move this data. So you don't have to go into 10 different locations to try to understand why your data didn't show up. You're able to go into a single application or a single platform and understand what's going on, see what connections are live and are moving data, and get a real-time view of what that data looks like. It merges machine data with transactional data with time series data. This is similar to what Rajesh had mentioned earlier, where you have all these different data sources, and it's important to be able to understand those data sources and merge across them. This is one of the key reasons why the industrial concept is really important, where you need systems that were designed for industrial, because it's unique to have transactional data, real-time process data, time series data all at the same time, and even files where you may have imagery or you may have sound files that you want to move up into the cloud for analytics. As the data is passing through, we standardize and contextualize that through models. And you can create models based on how you're planning on using the data. So they could be asset models if you're doing predictive asset maintenance. It could be product models if you're doing traceability or quality analytics. It could be process models if you're thinking about OEE. And then we flow that data out at the rate that it's needed. In many cases, you may have a dashboard in the cloud that you need to update once every 10 minutes. You may also have some analytics that you're running that needs very high resolution, 1 millisecond resolution data with 1 second bursts, so that you're able to understand the full machine dynamics that are happening. So it's very important to be able to flow information at different rates based on the use case. It often goes back to the use case of how you're using the data. That drives how you're structuring it, and that drives the frequency of flow. Now, as I said earlier, industrial data is unique, and the Intelligence Hub was designed specific for industrial data, and it was designed for the persona who understands, who's the domain expert of the systems that provide that industrial data. So what we see is that's often the SCADA engineers, the controls engineers, the automation engineers who are working with the solution architects to deliver this data. As such, it's got a codeless user interface. It allows you to integrate all these different systems on both the OT and the IT side, ingest that data, deliver it without writing lines of code and managing those lines of code. And it runs on the edge. It generally runs on premise, and it's designed to push that data up into the cloud so that you can hydrate those data models, hydrate those machine learning models so that they can learn, and then they can use them for predictive capabilities that they provide. Now, that's the general solution. Let me take you through a few use cases so you can see how this has been applied in a number of situations. The first use case that I want to talk about is a quality use case. We were working with an automotive tier 1 supplier, and they wanted to drive improving their first run yield, or their first pass yield. So the key was, in their environment, they had industrial automation in place to build the parts, as well as there was some manual activities that happened. And at the end of a line, they had a test stand. And in that test stand, they would test the parts. And if it failed, it would get set aside. And if it passed, it would move on. And that's their first run yield. Now, the challenge for them was that the test stand was built by the quality team, and the automation was put in place by the automation or the OT team. The test stand would log information. The older ones would log to a CSV file. It would write to the file. The newer ones would write to a SQL database. In any case, that data would not be available to the engineers who are trying to understand and improve the line for anywhere from a day to a week, depending on if it was a CSV file or a SQL database. So their challenge was they had no way of making changes in real time when a defective part came down, or even looking at what were the process capability or process dynamics that were utilized as that part was being produced, so that they could make adjustments as the test stand detected that it was trending toward the tolerances. So what they've been able to do is install the Intelligence Hub, ingest data from these different dissimilar systems with completely different teams that were working on those systems, but we're able to collect the data from these different systems, contextualize it, and then publish it up into the the AWS cloud. In this case, they were using the Amazon Kinesis, and then they were moving that into a Redshift database so that they could do the analysis. And what this enables them to do is improve their first run yield, both by understanding what the dynamics are of the line and being able to react before you even have a defect and bring the line back into the center of their tolerance curve. So very important, and they were able to really accelerate things, and the teams got access to a lot more data than they'd ever had in the past. Another very common use case is predictive asset maintenance. Now, this use case has been around for a while, and a lot of companies found that if they just put a sensor on a motor or on a pump, they were able to predict, or they were trying to predict, if the motor or the pump was going to fail. You know, we can see the bearing changes or whatnot based on the vibration or based on the power consumption of that motor or pump. What they found, though, is that they had a lot of false positives. And the reason for that is, or they were missing failures. And the reason for that is that they weren't combining the process dynamics of the line with the dynamics of that sensor. So what we're able to do is pull very high resolution data from this sensor. So in this case, this is that scenario I talked about earlier, where we're pulling 1 millisecond resolution data at a 1 second rate. So we're pulling a batch of data. That information was written to a CSV file, so we can pull in that CSV file. We can then combine it with what were the process dynamics of the line and what were the measurements that were being measured by other sensors on the line at the same time, because we're able to reach into the Pi historian and pull out that process information that's been logged in the historian. So now we're able to get a full picture of what's happening on that line and then send that information up to AWS. In this case, we actually package it up into a file and then load it up into an S3 bucket so that you can then run analytics on that data and better understand what's going on and monitor that machinery. Now, the key challenges of this use case where we need to combine data from dissimilar systems that are not connected. We often are reaching back in time to pull that data and push it up, because in this case, they didn't need, they could handle latency issues. It could be 10 minutes late for all they care. But what they needed to do is be able to merge data from different systems in a way that they were able to utilize that data to run their models in their predictive maintenance models. This case was they were monitoring a motor and it was a process plant. Another key use case that we're seeing is traceability. Now, traceability, especially of batch reporting, is often needed in things like the pharmaceutical industry, the food and beverage industry, the automotive industry, where you have regulatory impacts that require you to log information of what's happened as the product is coming down the line. What's further important, especially in batch manufacturing, is that you log information at the end of the batch or at the end of a phase of the batch, but you could potentially grab, the dynamics throughout the whole time that it was in that phase. So being able to keep the different, what batches are in what location very separate is critical to the delivery and logging of information. In this case, the customer was a pharmaceutical customer, and they had a lot of different equipment in different systems. So they've got some SQL databases to log information, like for their LIMS data. They've got their SCADA system. They've got some PLCs that have information that's not logged elsewhere. They've got analytical instruments that are generally logging either to a CSV file and into SQL databases, and then they've got their Pi data archive. And the key is to be able to collect the data from all these different systems, contextualize it, model it together, potentially even collect it over a period of time. So you aggregate the information. You may want to run a calculation like an average or minute of max while it was in that phase. Or you may want to take that entire set of data and move that up in that contextualized batch, depending on how you're using the information. And then once you've logged the information, you can publish that into either a unified namespace, or you can publish it up into the AWS cloud. And of course, in this case, we were publishing it to IoT Core, and then it was going to an S3 bucket. So very important to be able to log this information, to be able to pull data from multiple different systems at different times, aggregate it together, and then publish it to the target system as needed. And now we're on to the fourth use case. And this is where I often talk about, or we refer to as islands of automation. And people have been talking about islands of automation for a long time. In this case, it's reaching out beyond the actual automation of the factory and into all of the other ancillary systems and equipment that supports the factory. So AGVs are commonly used to move material either from one part of a line to another part, and they're used to move materials into the line and to pull products off the line. Now, AGVs are great because they're able to automate this movement of material around a factory, and they can move it, and there are a lot of great systems to be able to monitor these AGVs. But they generally are very standalone. So you have a system that's able to monitor it, and you've got a machine that's moving all around your factories. And there are a couple of challenges that happen. Sometimes those machines get into dead spots where they may stall, or they may not be able to connect to the network, in which case we need to know that there's some issue going on. At the same time, this customer wanted to be able to monitor how much are we actually using these AGVs and what are they being used for. And some of this knowledge and information wasn't able to be ascertained through the general software to control those AGVs. So in this case, we're able to connect in with the AGVs. They actually publish over an MQTT protocol called Sparkplug. So we could connect into the individual AGVs. We could also connect into the system that's controlling them through the SQL database and ingest that data. They had another challenge that they had to deal with, which was they had different networks. And this is very common in the manufacturing industry. So they have a device network where you have things like your AGVs and your equipment, and they separate that from the business network by what's called a DMZ, so that they can make sure that they segment things off in case there's ever a hack attack or there's ever any security issues. So what ends up happening is they can deploy an intelligence hub inside that device network. We can then publish out to an MQTT broker that could be in a DMZ, and then another intelligence hub. So we're federating our intelligence hubs. Another one can connect into that same MQTT broker and subscribe to that data. It can then combine that information with information from Pi and from other systems, so that you not only know what's going on with the AGVs, but you know what's happening within the whole line that they're servicing or that they're part of, and then publish that to Redshift. At the same time, it could be used to publish data into Pi. So in all of these use cases, we've seen how we can move data from different systems, contextualize and merge data together from different systems, and send it off to the target system for the use case that we're trying to solve. It's important to note also that we're not just about pulling data down from these systems, or pushing data up into the cloud, we can also pull data down into the cloud. So in this architecture, which has a lot of information on it, but it has a lot of information on it because it shows all the different connection points that HighByte has to the AWS cloud. So the base connectors are things like the IoT Greengrass and IoT Core, where we can publish MQTT messages up into both Greengrass and IoT Core so that they can ingest them and then make them available to the AWS cloud. That works really well for some customers, but others are using other services or they have very high speed data. Now, if you're using very high speed data, you may want to publish up into a Kinesis data fire hose, which can ingest a lot higher rates of data and can deliver it to various services within the AWS cloud. You may also be using IoT Sitewise, in which case, if you want us to publish into IoT Sitewise, we can do that as well. In fact, we can also build a model in IoT Sitewise and then start hydrating that model. So start pushing the data into that model. So the connection goes not only moving the data, but it's also creating the structure within Sitewise to consume that data. In addition to those services, we can also publish directly into Amazon Redshift. So we're able to push directly into that through our Redshift connector, and then we're able to, for data that latency is not as much an issue, and you have large quantities of it, we can write to a file, so a CSV or a Parquet file, and then publish that file up into an S3 bucket. So very easy, depending on the use case, to move data into the AWS cloud using multiple different services. And again, a lot of it depends on the volume, the frequency, the latency needs, the desired service that it's going to, and then we're able to select, what's the best path. It is important to recognize that not only that, but data may want to come down. So once you do your learning in the cloud, you may want to push information back down to the on-prem systems. In some cases, we've seen people push to the historian, to a Pi historian. We've seen people push to a SCADA system. And in very rare cases, we're even pushing to PLCs with set point adjustments. So this can all be enabled because we're able to take data from IoT Greengrass or IoT Core and push that back down into those on-prem systems. So just as well as it can be an output, it can also be an input for us, and we can move that data to the targeted system that's been designed. So to conclude with about the Intelligence Hub. The HighByte Intelligence Hub is designed to be your data infrastructure solution for digital transformation in Industry 4.0. It was built specifically for industrial data with the scale, with the systems, with the protocols, with the data challenges that we see in typical industrial environments. And it was designed for the typical domain expert in an industrial area, which tends to be an OT engineer. It's got a codeless UI. It runs on the edge. It's lightweight. It's easy to deploy. And it's easy to deploy and manage multiple hubs within a single site, within even a single line, but also across the enterprise. So it's enterprise ready. It's designed to deploy across your enterprise, standardizing your models, but also to link in with all of your IT infrastructure, your cloud infrastructure, all of your systems to monitor, maintain, and deploy systems. It links in with all of those and works seamlessly within your infrastructure. Now, the focus of the Intelligence Hub is to accelerate your cloud projects. So whether you're doing AI and ML, we need to accelerate that. We need to make it agile as well. We need to deliver data to the cloud that's usable, that's ready to be used, and doesn't need a lot of post-processing and information from the on-prem team. We need to accelerate implementation and scale of systems, and this is what customers are seeing it do. We need to eliminate various costly development. Now, development has costs on the initial deployment, but what companies are finding is that the costs are even greater when it comes to maintenance. When they custom develop, when they're trying to maintain it, because of the agility that's happening right now within the factory, as well as within all these data needs, they need systems that are highly agile in order to work within the environment that they have. It reduces the custom code and any technical debt. It improves your security and your resiliency. And it really becomes the solution that bridges the OT-IT gap to drive data to the cloud. And with that, Rajesh, I think I have completed the presentation. We're all done. We certainly would like to take questions in a minute, and also recognize that there's a lot more information that's available on the HighByte website, on our YouTube page, but also on the AWS website, where you can get that reference architecture diagram and a lot more information on digital transformation and all of the projects that companies are performing.
Sure thing, John. Thanks a lot.
Yes. And I'd also like to thank Rajesh and the AWS team for inviting us to do this presentation. This has been, hopefully this seems to have been a great way to get the information out to our mutual customers or our mutual prospects about how we can really accelerate their cloud deployments.
Great. Thanks all.
Thank you.